Dear colleagues, for your attention presents the research of Taras Shevchenko National University of Kiev on the subject of pre-processing method study to improve information technology for person identification by occluded image. The coronavirus pandemic has become a challenging issue for the face recognition and identification technologies. Most algorithms failed because of the presence of medical masks on the faces. Such an issue made it difficult for the decision-making systems to provide the correct results during the face recognition and person identification process. Also, for the past 3 years, many of these problems have been overcome. The new adversary attacks arose that allowed to evade the identification systems. Therefore, the development of information technologies for person identification, robust to the presence of occlusion on faces, is still up to date. Such problem is extremely relevant for today's Ukraine, where martial law is currently in effect due to the full-scale invasion of Russian troops on its territory. After all, the faces of military personnel are usually almost completely covered by protective equipment, which makes it difficult to identify them. Accordingly, the same algorithms will not be resistant to recognizing military personnel who usually wear helmets and balaclavas. In our previous work, the information technology for identification of a person based on an occlusive image of a person's face was proposed. This technology is based on an algorithm consisting of anisotropic diffusion as a method of image preprocessing, Gabor wavelet transformation as an image processing method for forming a global face image, local binary patterns in one-dimensional space, and a histogram of oriented gradients for forming a vector of image features. Preliminary results of the algorithm's work on occlusive images were that the identification accuracy rate of the proposed algorithm ranges from 72.5% to 85% depending on the database that were used during the experiment. The purpose of this work is to improve the stability of the algorithm, which is the basis of the information technology of person identification, to the presence of occlusion due to the pre-processing methods. With the aim to improve previously obtained results, it was decided to conduct experiments changing the image preprocessing method, since the purpose of preprocessing is to modify the presentation of the initial image to facilitate the execution of the next stages of the algorithm. Originally, in the proposed algorithm, the anisotropic diffusion method is used, that is based on equations with partial derivatives. The main idea of this method is to present the image in the form of a pixel brightness intensity map. To fulfill the purpose of the study, it was decided to use histogram equalization apart from anisotropic diffusion and along with it. As a result of equalizing the histogram, in most cases the dynamic range of the image is significantly expanded, which makes it possible to display previously unnoticed details. As far as both anisotropic diffusion and image histogram equalization are often used to increase the detail feasibility of an image, it is appropriate to check whether appliance of two of these methods can improve the efficiency of the algorithm. Experimental research was conducted in 3 stages, with the use of anisotropic diffusion, image equalization, and combination of both methods. To conduct experiments, 3 databases were used as well as in the previous research. As far as selected databases do not contain images with such occlusive attributes as medical masks or balaclavas, they were previously cropped and converted to the single resolution in the way that after this, images would only contain the areas not covered by occlusive attributes under research. Also, the formats of the images in the used databases are vary. Since types of images can be uncompressed or compressed, and that fact can have an impact on the results of the experiments, it was decided to convert initial images to common uncompressed and compressed formats to perform the experiments more objectively. Figure on the screen presents the results for the initial and occluded images from the database of faces that were pre-processed with anisotropic diffusion equalization and the combination of these methods. After the images were occluded, identification accuracy rate for the JPG converted images reduced on 2.5–7.5%. On the other hand, results for the BMP and PNG converted images improved on 5 and 7.5% after appliance of the equalization and combination of 2 methods respectively. Current figure depicts the results for the initial and occluded images from the FERET database that were preprocessed with the same methods. From comparing these results, the following conclusion can be made. initial algorithm with anisotropic diffusion itself provided the highest identification accuracy results on the original images in all sets of the experiments. But the appliance of the equalization method improved the result for the JPG-converted images up to 77.5%. Next figure demonstrates the results for the original and occluded images from the SC phase database that were preprocessed with anisotropic diffusion, equalization, and the combination of these methods. Analysis of these results provided the following conclusions. The highest identification accuracy rate of 92.5% was obtained with the use of anisotropic diffusion only in all sets of the experiments on the non-occluded images. The same for the occluded images. Neither equalization method nor combination of two methods improved the result. It is stably equal to 82.5%. The results of conducted experiments allowed to make the following conclusions. After algorithm was applied on the occluded images from the database of faces that were converted to the uncompressed formats, it provided the identification accuracy rate on 7.5 increased with the use of equalization only in both of research methods. On occluded images from the Ferret database, the efficiency of the algorithm did not improve. Therefore, after images were converted to compressed format, that is JPG, and its histogram was equalized, the identification accuracy of the algorithm increased on 2.5%. Appliance of image histogram equalization only or in combination with anisotropic diffusion did not improve the identification accuracy rate of the algorithm on the occluded images from the SC phase database. Thereby, for the following studies, it is needed to consider the parameter setting of the selected pre-processing methods and consider other methods as well. That is all. Thank you for your attention.